So here we have a Scratch project that is pretty simple. I want to demonstrate that by running it first. So it's a ball and a paddle. Ball bounces around the screen, and I'm trying to not let it fall through to the ground. If I do, then I lose. Okay, so it's a pretty fun game that's pretty simple to do. If we look at the code, there aren't that many blocks, right? As you can see, you can kind of glance at it even if you don't know programming. The logic is very understandable from the English that it's describing each block's width. You can also see that the placement of the paddles, if you want to reset it, you can actually get away with just like dragging and dropping and like maybe resetting these numbers back to 0. There's a better way to do this with code. So now let's see what a similar program would look like in a professional language like Java. So you can see here the code is intimidating for somebody coming from a drag and drop platform like Scratch. Okay, so we got the paddle, we got the ball. So it's really overwhelming for students coming from blocks like this to code like this because they have to do a lot of typing, right? A lot of attention to detail. If they spell a little thing wrong, their entire program doesn't work. They have to know a lot more about coordinates and just general attention to detail, like the curly braces, they all need to match, right? So that's why we created Java blocks. We can actually write the same code in blocks and it gets translated to Java like this, okay? So despite the similarity that you're seeing, so this is a drag and drop block-based platform. It looks very similar to Scratch, but there are a lot of things that's uncommon about the two. Let's start with the ball and the paddle. In Scratch, those are objects called sprites in their platform. It kind of abstracts that those things are actually storing states about a program. In programming speak, we call those variables. The number of blocks that we use here seems to be more than what we have in Scratch. There's a lot more numbers and there's less English that tells you what each block does. Then why still use blocks then? There's an element of discoverability with the blocks still. So for example, with a command called fill, and right now the numbers we input are 100 and 0, 0. Let's say you don't know what the fill command does. Maybe you can find out, you can discover by changing a number and see what happens. So I can actually see that the number that's displayed here turned red. Okay, so this looks like it's changing the color of the text. Another thing you see with this code here is students in general, they need to know coordinates at a much better level than they would otherwise need to in Scratch. With the blocks, it makes it so that it's not as overwhelming. So there's just less typing. If students make a mistake where they nest a block instead of putting it sequentially, it's also an easier mistake to fix. And mathematically, you can actually tell that Scratch is a really nice platform. You can get away with programming a simple program like this without actually even knowing like coordinates. It has a block here that says like if on edge bounds. That's really nice to take out the more complex middle and high school math that would be required of the student otherwise. If we were to do the same thing in Java, it would actually be a lot more complex. So this logic here, which took about 6 blocks, you can do that all in one block in Scratch. So this is why we created Java blocks.